All right, hello everybody. This is going to just be a step-by-step tutorial on how to do the dimensional analysis worksheet. So if at any point you're like, Miss Brennan, I know exactly what I'm doing, I can log off this video. Or if you're just not sure of what you're doing yet, just stay on through the whole video and just pass in whatever you complete at the end of this video. Again, we're going to be doing a lot of this constantly throughout this year. So there's no stress to it right now if you don't understand. I totally get it. There is a lot going on right now, especially with the first week. So again, no stress, but let's get started. So on this first page here, I just have all of the dimensional analysis problems and conversion factors that we are going to need throughout this entire worksheet. So I am going to just constantly be referencing back to this. Again, you do not need to memorize these conversion factors. They will always be given to you, but let's get started. So number one, how many miles will a person run during a 10-kilometer race? So like most things in physics, we have to start out with what we are given. Okay, so in this problem, we are given 10 kilometers. So we'll just do 10 km. And then with that, we are asked to convert kilometers into miles. So in order to do that, I need to cancel out those kilometers. So I need something here that has to do with kilometers and something here that has to do with miles. So let's go back to our conversion sheet. And I see right here 0.621 miles is equal to 1 kilometer. So I can use that to cancel it out. So 0.621 miles is equal to 1 kilometer. Awesome. So now I can cancel out these kilometers and I can finish up my work. Just do the math. 10 times 0.621, and I get 6.21 miles. So in 10 kilometers, there is 6.21 miles. All right, let's move on to number two. The moon is 250,000 miles away. How many feet is it from the Earth? So we have to start out with what we are given in the problem. So we are given 250,000 miles. And then what is it asking us to do? It is asking us to convert it into feet. All right, so in order to do that, I'll just add my little multiplication sign. I need something here that is feet on top and miles on the bottom in order to cancel out these miles and leave me with feet. So let's go back to our conversion chart. And I can see here that 1 mile is equal to 5,280 feet. So I'll just put that right in here. So 5,280 feet is equal to 1 mile. And that's a 0, I'm sorry. That's a 0 right there. All right, so again, these miles cancel, and I am just left with feet. But there is nothing on the bottom here, so I can literally just call this 1. I can leave it blank.
Good afternoon, Derek Mariani, please dial 413.
Sorry about the announcement, guys. Hold on. Okay, so I am now left with feet. So in order to just complete the math, I just have to go 250,000 times 5280, and that would give me the number of feet away the moon is from the Earth. So I'm going to break out my calculator and I'm just going to complete this. So 250,000 times 5280. So I get 132, 1, 2, 3, 4, 5, 6, 7. Okay, now I can convert that into scientific notation by calling this 13.2 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 to the 9th. Okay? All right, let's move on. Next problem. A family pool holds 10,000 gallons of water, and it's asking how many cubic meters is this? So we are asked to convert 10,000 gallons And it's asking us to convert it into cubic meters or meters cubed. Okay, so meters cubed over something with gallons. Okay, so I'm going to go back to my conversion chart and look for something that gives me gallons and meters cubed. So I see here 264.2 gallons is equal to 1 cubic meter. That can help. So 264.2 gallons. So 264.2 gallons is equal to 1 cubic meter. So I just have to complete the math because these gallons cancel and it leaves me with meters cubed. So I get 10,000 over 264.2 meters cubed, and I'll just finish out that fraction by dividing. So 10,000 divided by 264.2. So this leaves me with 37.9 or 85 meters cubed. Okay, let's go on to the next one. The average American student is in class 330 minutes per day. How many hours per day is this? So we are given a time. So we are given 330 minutes per 1 day. And it is asking us to convert into hours per day. So we will do that. Hours per day is what we are asked for. So basically all we have to do is take care of these minutes because we can leave the days right where they are. So 1 hour is equal to, I'll just get rid of these right here because we want that in the end. Actually, I have an eraser. Let me just get rid of that. So we'll use the conversion factor of 1 hour equals 60 minutes. Okay, so these minutes cancel and I'm left with hours per day, which is exactly what I want. So I do 330 times 1, which is just 330, all divided by 60, and I am left with hours and days. So 330 divided by 60, that would give me 5.5 hours per day. Okay, so let's move on. The average American student is in class 330 minutes per day, but how many seconds is this? So again, so we have 330 minutes per 1 day, and we are asked to convert it to seconds per day. Okay, so we'll just multiply this out. We want to keep the days there, so all we have to do is finish out these minutes. So we know that there are 60 seconds in 1 minute. So doing that conversion out, that gets rid of our minutes for us, and we are left with seconds per day. So all we have to do is complete the math. So times 60 all over 1, and we are left with seconds per day. So completing that out, we get 330 times 60. So how many seconds per day? 19800, or 19,800 seconds per day. Okay, let's move on to the next one. How many seconds are there in 1 year? Interesting question. So we are given 1 year, so that is what we will start with, 1 year. And so how would we cancel out years? Well, we can start by knowing that there are 365 days in 1 year. But that doesn't really answer our question. We're trying to find out how many seconds in a year, so we have to keep going. So our years cancel here. Awesome. But now we have to figure out how to cancel out these days. So there are 20, here, let's see. in our conversion here. Sorry, I just wanted to see how much time I had left. Okay, so let's get back to it. So there are 365 days per year. Again, we have to figure out how we can cancel out days. So how about there are 24 hours in one day? That will cancel out days for us. And then how many minutes are there in 1 hour? So there are 60 minutes in 1 hour. So that'll cancel out the hours for us. And now we just need to cancel out the minutes. So there are 60 seconds in 1 minute. So all we need to do is just do the math. So we have 1 times 365 times 24 times 60 times 60 again. And we can see here that these minutes cancel out. So all of our units cancel out except for the seconds, and that is exactly what we want. So this number all multiplied together gives us, let's find out, 1 times 365 times 24 times 60 times 60 gives us a big number. So that is equal to 315360000 seconds. So that is how many seconds there are in a year. Okay, next problem. 6 minutes per hour is how many feet per second? Oh, sorry, 60 miles per hour is how many feet per second? Oof, sorry, 60 miles, we have to start with what we are given, per 1 hour, and it's asking us to convert into how many feet per 1 second. So let's start by getting rid of the time, because that's probably just the easiest thing to get rid of at this point. So we know that there are 60 seconds in 1 hour. 60 minutes in 1 hour. And then we have to cancel, so that would cancel out our hours. And then we have to cancel out our minutes and get them in 2 seconds. So in 1 minute, there are 60 seconds. So that'll cancel out these minutes, and then we're just left with seconds here. But that doesn't completely answer our question. We need to know how many feet there are, or how fast this is going in feet per second. So in order to do that, 1 mile is equal to 5,280 feet. So all we have to do is do the math. So 60 divided by, or we're going to divide 60 times 60 times 5280. So we get 60 divided by 60 times 60 times 5280. And we get 3.15 times 10 to the negative 6 feet per second. So very, 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 very slow.